All right, 9-2 practice. Let's get after this. Hopefully I can clear up any questions that you have, and you can check your answers. So number 1, find the value of each variable of a parallelogram. So remember, parallelogram has opposite sides are equal. So if the bottom's 15, then y has to be 15. Same thing on the left and the right. These opposite sides have to be equal. So if this side is 9, x has to be equal to 9. All right, moving along to number 2. The other feature about parallelograms are that opposite angles are also equal or congruent. So I know that this 70 has to be 70 down here. So when is 2m equal to 70? I divide both sides by 2, and we will find out that m equals 35. Another property about parallelograms are that consecutive angles, angles next to each other, are 180. They're supplementary. So I know that this 70 and this n have to add up to 180. So n's got to be 110. So that way we have the 110 and the 70 make 180 degrees. So n is 110. Number 3 looks a little bit trickier because I don't have any numbers for any of the angles. So there's a couple facts that I do know. I do know that whenever you have 4 sides, the sum of all the angles needs to add up to 360. So that's one thing that I know, the sum of the interior. The other thing I can use here is that I do know that these 2 angles down here at the bottom, so this angle and this angle, they're next to each other, so they have to add up to 180 degrees. So when I add those up, I have b minus 10 added to b plus 10. Those need to equal 180 degrees. So when I kind of clean that up, I end up with 2 b's. The minus 10 and the plus 10 cancel out, equals 180. And then divide both sides by 2, and I get b equals 90 degrees. So that's kind of helpful because when I substitute that back in, b equals 90. Well, 90 minus 10, that tells me that this corner is 80 degrees, which because opposite angles are equal, I now know that this corner is 80 degrees. And if I substitute b in for right here, I get 90 plus 10 is 100. And opposite angles are also 100. So you can see it's doing what it's supposed to do. Opposite angles are congruent. Consecutive angles or angles next to each other equal 180. So everything's checking out rather nice. All right, we'll keep it rolling down here at the bottom. So it looks like I have opposite sides. 20 has to equal this side. So 20 has to equal z subtract 8. And add 8 to both sides. You get z equals 28. Talking for angles here, if this is 105, this angle's got to be 105. So 105 degrees has to equal the d minus 21. Add 21 to both sides, and we get d equals 126. All right, now we get into another feature of parallelograms from the video notes, and that was that the diagonals bisect each other. Okay, so they bisect each other or they cross at a midpoint. So kind of using that fact, I know that if this segment is 8 and this is a midpoint, this segment also has to be 8. So m equals 8. So notice that the total length of that diagonal, so the red diagonal, has a total of 16 long, if I were to do this whole piece. If I look at the blue diagonal, if this side is 11, that means this other side also has to be 11. So when is k plus 4 going to equal 11? Well, if I minus 4 from both sides, I find out that k equals 7. So I solve for the variable. But if I wanted to know the whole diag, we'll call this diag number 2, or the blue one, it's going to be a total length of 22. So I just wanted to point that out, that in a parallelogram, you usually have a short diagonal or a long diagonal, unless it is a rectangle, and then they're going to be congruent, or a square. All right, scrolling down. Looks like we kind of have a story problem on this one. So J and K are consecutive angles in a parallelogram. So let's just sketch that out really quick. Parallelogram. Consecutive angles mean they're next to each other. So let's just call J and K. We'll put them down here. As long as I put them side by side, I'm good. If you're 3x plus 7 and you are 5x minus 11, well, what do they have to do? They're not equal to each other. Remember, consecutive angles have to add up to 180. So I'm going to make J plus K equal 180 degrees. So when I add those two up, I have 3x plus 7 added to 5x minus 11. Those got to add up to 180 degrees. So let's combine some like terms here. Gather up my x's, I have 8x. Gather up my constants, I have a negative 4. And now I'm just solving algebra. Add 4 to both sides. So I'm going to get 8x equals 184. And then divide both sides by 8. And I'm going to get x equals, what's that going there? 2, 3. So x equals 23. I still haven't answered the question though. Find the measure of each angle. Always go back and see what do they really want me to do. So to find the true measures of the angles, I'm going to need to take this 23 and I need to plug it in for x in both spots. So let's just do that. 5 23s, well that's 115, take away 11. So that's 104 degrees. And then 3 23s is 69 plus 7 would be 76. And life looks pretty good because they do add up to 180, 76 plus 104. Now I also could get the other angles because of the properties of a parallelogram. The opposite angles are also equal. So looking pretty good on that one. Number 3, going on the coordinate grid, find the coordinates. So basically they want me to find an XY pair. All right, that's what we're trying to figure out here. What are these two numbers? That are the intersection of the diagonals. Well, intersection of diagonals basically means it is the midpoint. We learned how to do this in chapter 1, so I'm going to go back and refresh it. So let's first draw the parallelogram. W at negative 2, so that's left 2 up 5, left 2 up 5. So there's W. X is at right 2 up 5. That's not too bad. That's X. Y is at 4, 0, right 4, don't go up or down. And then Z is at 0, 0. So there is my little miniature parallelogram here. It's kind of small, but oh well. And I need to kind of figure out where do those two cross at. So if I were to put the diagonals on here, and I were to connect from here to here, and from there to there, I'm trying to figure out where is that point. That point is going to be my answer. And basically it's just the midpoint. So just a quick refresher, to find the midpoint, and I really don't need to find both of them, let's just find the midpoint of this segment from Z to X. So if I want to find the midpoint of segment ZX, basically it's just the average of the X coordinates and the average of the Y coordinates. All right. So the X coordinates are, remember Z here was at 0, 0, and Y here is at 2, 5. So if I want to average the X coordinates, I add them up and I chop it in half. So 2 divided by 2 is 1. And then if I want to do the Y coordinates, the average of 5 and 0, 5 divided by 2 is 2.5. So that right there should be the midpoint. And it looks pretty good. Looks like it's over 1, up 2.5. So basically that's how you find the center of the diagonals, is you find the midpoint. All right, number 4, another word problem here. J and K are consecutive. Well, this looks like a repeat. We've already did this one, so don't have to do it. That's nice. Number 5, the sides of a parallelogram are represented below. Sketch it. Find its perimeter. All right. Well, let's sketch this thing. And where you put M, N, P, and Q doesn't matter. You just have to go in order. So if I start here at M, I need to either go clockwise or counterclockwise. So I got that. We label our sides. So MQ is this. 37, whoops. And QP is y plus 14. And then MN is 4y plus 5. And then the last one, NP, is x minus 5. Now, my ultimate goal is find the perimeter. So remember, to find the perimeter, we need to add up all the sides. Well, I can't really do that yet because I don't know how much the sides are. So my goal here, what I'm going to do is I'm going to try to solve for x, plug it back in, and then do the same thing for y. So kind of what we did earlier, we're just building on that. I know that NP has the equal MQ because opposite sides of a parallelogram are equal. So I know that x minus 5 needs to equal negative 2x plus 37. And now we solve this. So I'm going to add 2x to both sides. And I get 37 equals 3x minus 5. And then I'm going to add 5 to both sides. And I'll get 3x equals 42. Divide. X equals 14. So if x equals 14, 14 take away 5 is 9. So now I know how long NP is. In MQ, I could plug it in, but I'm going to trust myself. It should also be the same thing. Well, now I got to play the same game with the y's. So I know that this side has to equal this side. And I'm going to go ahead and solve this. I'm going to minus a y from both sides. And I'm going to actually do 2 steps here. I'm going to minus the y, and I'm also going to minus the 5 to take care of that. So 3y equals 9. And you cancel those out. And then I'll divide both sides, and I get y equals 3. So plugging that in, 3 plus 14, well, that's 17. And then 4 times 3 plus 5, that's 17. So now we can go back and we can find the entire perimeter by adding up the sides. We basically have 9 plus 17 plus 17. What's that? 34 and 18 is 52. So the perimeter, 52. A little bit tougher problem. Had to put quite a few things together. All right, number 6, find the missing vertex of a parallelogram. So that's basically just a corner. So they're giving us 3 of them. So if we go, D right here is left 2, down 4. Left 2, down 4. And F is at 0, don't go left to right, go up 7. So there's F. G is at 1, 0, over 1, don't go up or down. This is a weird looking parallelogram. So if I kind of sketch out what I have so far, I have these people. Well, I got to go in order. So I can't just cut from D to G. I need to go in order. And notice the order, I'm missing E. So I need to go from D to E, E to F, F to G. All right, and then go back. So basically, you know, I have from F to G, and this is going to reconnect from D to G. So I got to go from D to E. Well, basically, I need to kind of keep this line the same thing on the other side because it needs to be parallel and it needs to be the same length. So one key feature, remember, in a parallelogram, you have opposite sides need to be equal and they need to be parallel. So to be parallel, I'm just going to run the same slope. I went left 1, up 7 units. So from here, I'm going to go left 1, up 7 units. Should land me right to there. And when I connect those, I think I now have a nice parallelogram. So I can find out where E is. That point right there, which is what we were after, that was the vertex, is at left 3, up 3. So left 3, up 3. That's your final answer. All right, show. This basically says, hey, prove that something is a parallelogram. Well, to prove something's a parallelogram, I have to show that, by definition, it's got opposite sides equal and parallel. So if I can show that I have opposite sides equal and parallel, pretty good to go. So let's just kind of check this out. So first of all, if we look at KL, I think I can tell you a couple facts about KL. I think I can tell you the slope, and I think I can tell you the length. And I'm going to kind of use the same numbers to do both. So the slope of KL goes up 2 over 6. So it has a slope of 2/6. I could reduce that to 1/3 if I want, but I don't want to. Because also, if I want to find the length of KL, that is just the hypotenuse of this little right triangle. So I can use the Pythagorean Theorem. So I can say that the length is going to be 2 squared plus 6 squared. Probably should go back to fatter marker here. 2 squared plus 6 squared equals KL squared. And then we just got to solve it. So that's 4 plus 36, that's 40, is KL squared. And then I take the square root of both sides. So KL equals radical 40. Which is somewhere a little bit bigger than 6. I'll go to my calculator, double check it out. Radical 40. It's looking like it's 6.32. 6.32 is the length of KL. I really didn't need that, though. I could just call it radical 40. Well, if I look down here at JM, if I look down here and kind of check JM out, it's the same idea, okay? It has a slope of a rise of 2 and a run of 6. So it looks like JM kind of matches right here. JM also has a slope of 2 over 6, which means it's going to have the exact same length. So right now, what I've proven is, I've proven that these two sides are equal, because they're both 6.32. And I also know that they're parallel, because they have the same slope. Now actually, if I want to prove quadrilateral is a parallelogram, I really only have to test one side and make sure that it's both of these, you know, equal and parallel. But you could do the blue too. I'm just going to do this super fast. Slope for this line, it drops 1, 2, 3, 4, 5, 6 over 1. So KJ has a slope of, it goes down 6 over 1. So slope of -6. And so does LM. LM also has the same slope. So I know that they're parallel. And if I want to find out how long they are, I could kind of play the same game. I could do my little triangle. And it's just a 1/6 triangle. So if I want to find the length of KJ, go a little fatter here. KJ is just going to be the square root of 1 squared plus 6 squared. I'm kind of just jumping right down, taking the square root of both sides in the Pythagorean theorem. It's kind of speeding it up a little bit. So it's a square root of 37, which is just going to be a tiny bit bigger than 6. So square root of 37 is 6.1. So there you have it. I've proven you're a parallelogram because you have the same slope, the same length, opposite sides, parallel, and equal. Get off me. Number 8, is there enough information? Don't worry about this section. We're going to kind of skip this part. So don't worry about that. Move on down to number 9. Ooh, pool. I like playing pool. Not very good at it, but I like playing it. A lot of geometry in it. If you're ever bored, you can Google Donald Duck in Mathmagic Land. There's a scene in there where he's playing pool. It's pretty cool. I remember it from elementary school. So you shoot a ball, it rolls back to where it started. The ball bounces off each wall when it hits the wall. A, the ball hits the first wall at an angle of 63 degrees. All right, so it hits the first wall at 63 degrees. So here's our cue ball. And our very first hit, it's going to hit the wall at 63 degrees. And AEF equals BEH, which equals 63, because that's how when something bounces off a wall, it reflects at the exact same angle. So that's why those two are both 63 there. It keeps doing that all the way around. What is the main measure of angle AFE? Well, we do have a little triangle here that if we kind of focus on this, and pool tables are built to where they have a 90-degree corner. So I should be able to find this angle right over here by doing 90 minus 63, which would be 27 degrees. You know, I could have added 63 plus 90 and subtract from 180, but since one was 90, I knew the other two were going to be 90, so I kind of shortcutted it right here. So if that hits at 27, it's going to bounce off at 27. I'm going to kind of not read the questions over here. I'm just going to kind of keep going with the triangle stuff. Now we have another triangle. And so I think I'm going to have another 63, which is going to give me another 63. It's going to give me a 27. Give me another 27. So I kind of got this thing on lockdown. So let's see what we answered the questions. AFE is 27 degrees. Part A done. Why is FGD 63? FGD, where is that angle? Well, that's right here. So why is that 63? Well, because the triangle has the equal 180. What is the measure of GHC? I've already got that on lockdown. G to H to C would be this angle. So that's 27. EHB, also 27. Is it a parallelogram? Explain your reasonings. Well, let's see what we got. If we look at angles here, angle H I think we could find. So angle H, these three make 180 degrees. So basically I have 180, take away the 27, take away the other 27, which is just 180, take away 54, which is 126, which is going to make this angle 126. And if I do the same thing, 180 minus the two 63s, so that's 180 minus 126, which is going to give me 27. No, it's going to give me 54. So yes, it is a parallelogram. Why? Because opposite angles are congruent, or consecutive angles add up to 180. Either one. So that's another way to prove something's a parallelogram, is focusing on the angles. I couldn't do that up above in this problem because the coordinate grid we didn't have the angles on. You know, so in this problem there were no angles. I had to focus on the side lengths. So that was my only option. All right, I know this video was kind of long, but hopefully it helped you out. So leave some comments in the discussion feedback, and I will answer your questions. See you.